Hey, what's up, Franklin West? So this is the part 3 that completes the proficient level of solving linear equations according to the grade 9 curriculum at BFA Fairfax. So again, all people are welcome to take a look to see what they need to do to get ahead, challenge themselves, or get refreshers. So this last equation that we're going to solve has many more steps. The left side is very busy, as is the right, and sometimes we don't get super clean, beautiful answers. So this one may not end in a whole number. Enjoy the
Here it
video.
is, our last problem in this series of solving linear equations at the proficient level. So we have negative 8x plus 3 minus 5x is equal to 7 plus 2, all times the quantity x minus 7. So as promised, the left is just as busy as the right. But we're going to take it in steps and try to clean up each side before we start moving things to other locations. So I guess we'll go back to the blue. And as I look to the left, I see a negative 8x and I see a negative 5x. Now, do keep in mind that the signs in front of each number belong to only that number. So that's a positive 3 here, making that negative belong to the 5x. So even though that's 3 subtract 5x, you really got to start training your thinking and your eyes to recognize that that's really a negative 5x. And so it's a negative 5x being combined to a negative 8x. So if you're thinking about it in piles of negative items, well, I got 8 negatives here, 5 negatives here, for a total of 13 negatives. Okay, so I have negative 13x. I've done nothing with that 3, and it's a positive 3, so I'm just bringing it down. So negative 13x negative 13x plus 3. That will equal the right-hand side that we have to clean up now. So we've got this 7. It's kind of on an island. I know I've said that before in these video series, but it's really important to name it that when I've got this quantity of x minus 7, whatever's only just immediately outside of it is what's being distributed in, which means the 7 has nothing to do with that. Okay, so the 7 can just come down. Now, right now, this is a positive 2, and it has to be multiplied and distributed to each term within this parenthesis grouping. So when we do these arrows, they don't fix our problem for us, but they help us remember that this is a two-step process. And so I have to do a positive 2 times a positive x. Well, that sounds familiar. That'll be a 2x. And because it's positive, I'm going to write plus 2x. Notice I'm not writing the next sign, right? I'm going to wait until I distribute the 2 to the negative 7, find out what that number is, and let that number determine the sign that I write here. So for example, that's a positive 2 times a negative 7. So a positive times a negative is a negative. So this becomes a negative 14, which then I'll write. So notice that becomes 2x minus 14 because it was a negative 14. So we've distributed on the right, we consolidated on the left. There's still more work to be done, of course. So there's nothing more I can do on the left-hand side. Those are not like terms. This negative 13x has the variable, and this 3 is a constant. There is no variable. So I'm going to do the thing a lot of students don't love, and that I'm going to rewrite this without any changes. Sometimes people don't like to do more work, especially if nothing is different. And I totally get that. But you want to make sure that every single line we create is equivalent to the line above and therefore equivalent to the original problem, because this is all about balance and equality. And although those are great social terms also in math, they really help guide us to solve algebraically in a correct manner. So that just comes down. No work there until step 3. So let's figure out the right-hand side. So we're going to scan this for like terms. I see a constant of 7 and a constant of negative 14. They are like terms. We should combine them. We get to assume that's a positive 7. It's combining with a negative 14. So I could think of it as 7 subtract 14. And so that will lead me to a negative 7. And the 2x, well, We won't deal with that till step 3, but it needs to be represented in this line also. So now we're at the point that we've seen in all 3 problems in this video series, and that is we've got a term and a constant equal to a term and a constant. So now we're at the point where our like terms are on opposite sides of the equal sign. So 3 and -7, 2x and -13x. So now we're in the undoing phase of solving. So I like that this is a -13x, and so I will decide to make that a 0 by adding 13x. I can't promise that I can always eliminate encountering negative signs, but I noticed that if I add 13x rather than subtracting 2x, which you can do, there's nothing wrong with it, but in the way I'm outlining it here, I get to avoid negative numbers, at least for a little bit. And I like that. So -13x plus 13x is the 0 we were looking for when it comes to adding and subtracting as a way of undoing. So that leaves us with a 3 on the left. I've done nothing with the the -7 on the right-hand side. And so now I consolidate and I have 2 plus 13, or 2x plus 13x gives me a 15x. Excellent. Okay, so now we're going to combine like terms again, but this time of the constants. So because I moved all my variables to the right-hand side, it's in my best interest, if I want to reduce how many steps I have to do, to move the constant to the left, move it in the opposite direction. So see how I was able to get positives? I got really lucky because of me choosing to add 13x rather than subtract 2x. I otherwise would have had a negative equal a negative, which is totally fine. And actually, I challenge you to solve it that way. There's nothing wrong with doing negative numbers all the way through. But as you get to know yourself as a learner, you might find that you're tending to forget the negatives when you need it, or make errors with negative numbers. And so any chance you can avoid the pathway, you should take it. Okay, so now we're left with 10 equals 15x. So again, 15 is right up next to the x. 15 is the coefficient, x is the variable. Their relationship that's hiding in this space is multiplication. And the way that we get to undo multiplication is from division. So using our fraction bar, we're going to divide both sides by 15. Now, no, you can see already we are not going to get a whole number here, but that's okay. So this 15 divided by 15 gets us the 1 that we are intending, right? So when you're undoing multiplication and division, you can create the 1, which is what we're looking for, 1x. So that 10 over 15, there's no sense in going into the decimal. I know sometimes people really like to get into the decimal, but I'm going to outline it here and keep it as a fraction. So I'm going to look at that 10 over 15 and recognize I can reduce it. So 10 and 15 are in the 5s family. So there are 2 5s that live in 10 and 3 5s that live in 15. And so if I remove a 5 over 5, a value of 1, then what I'm left with is 2/3. And so I get x equals 2/3. So I did warn us that we might not necessarily get the cleanest number, and that is okay. So a fraction can be the right answer. And it's good to get familiar and comfortable with that, because oftentimes students can get so used to practicing whole number solutions or answers that the moment they get a decimal or a fraction, they instantly assume that they've made a mistake and something's wrong. So it's good to practice getting numbers that aren't as clean as a whole number. That way you don't have to automatically go into second guessing, because really every single value on any number line that you could imagine could be an answer to an equation. So let's do a check. We'll work in purple. We haven't done that in a moment, or I guess we did it above. So this check is going to be a little long because we got a long equation and I write big with this cursor. So x is 2/3. So every time I substitute, like I have been in these other problems, I'm going to use parentheses. So that's -8 times the value of 2/3 plus 3 minus 5 times 2/3. And that equals 7 plus 2 times the quantity of 2/3 minus 7. Now, how many of you hate this already, right? It doesn't look pleasing. We've got fractions. We're going to bring back all this practice from years ago that maybe we had a mastery of and have forgotten, or maybe we never quite got the fractions when it was the focal point of our math learning. Well, either way, it's good to revisit to see. Sometimes we're just ready to learn it years later, and that's so maybe something will click if it hasn't before. So I'm not going to get into decimals because if I did, 2/3 is not the equivalent of 0.6. And I know that a lot of you might want to write that down, but 0.6 is not the same value. It's overly rounded. 2/3 is 0.6666666 on forever. And so we are not going to be able to capture its true value in that way. And if you use 0.6 in this check, you're going to think you proved it wrong because it just won't work in the check. So we're going to keep it in fraction because that really is the accurate representation of the value. So -8 is really over 1. You could imagine that in your mind, that is a fraction itself. And with that, I'm just going to multiply -8 times 2. So I'm going to get a -16. And when I do 1 times 3, I get thirds. So you're going to see that we're going to create fractions that are in thirds. I have a 3 here. I'm just going to leave it down because I'm not going to touch it for a little bit anyway. I have a -5 times 2/3, same thing. -5 times 2 is -10, and that's over 3. Notice I'm not doing 5 times 2 and 5 times 3. That would be incorrect because, again, this is 5 over 1. And the rules of multiplying fractions is numerator times numerator, and then denominator times denominator. Okay, so it's not looking too bad, right? Hopefully I haven't lost you yet. Now, some of us might want to try to figure this out because, of course, our rules say work inside parentheses first. Well, you totally can, but then I got to get 7 into thirds also and then do a subtraction, and I totally can do that, and you can do that too. I challenge you to pause the video and do it that way. Do 2/3 minus 7 and then multiply times 2, and then compare answers with what I get in this other process. So that's the nice and challenging thing about math. Sometimes students love that there's so many different ways to get the right answer because that means they've got a pretty good chance of getting it right, depending on how their thinking is. Whereas others only want to know one way, and to hear more ways is just overly complicated. So learn that about yourself and know it enough to structure your learning, but also I encourage you to work on that. That would be a good challenge to become not so distraught over knowing that there's more than one way, for example. So I'm going to actually do I'm going to distribute it 2 times 2/3. So again, that's 2 over 1. So that'll become a 4/3. So I'm still going to have 3 terms on this side. If you guys were doing it the other way, you'll in the end get just 2 terms or 1 term instead of 2. So then we have 2 times -7, which gives me my -14, which is something we've seen familiar in the problem. Okay, so still looks like a hot mess, but we're going to be okay. So one of the things we might want to do is look at that 3. I can't actually add that 3 in right away, and maybe so I'm not overly complicating this for anyone, I'm going to ignore adding the 3 just for a moment. So we are going to combine the fractions that are combinable as they are currently written. So I have -16. I'm going to combine that with a -10. So I have a -26 thirds, and that's a +3. And I'm going to do that over here. Notice I've got 2 whole numbers I can combine nicely. 7 minus 14 is -7, and I have a 4/3 to add to that. Okay, so how do we do this? We've got whole numbers adding or subtracting to fractions. Well, the best way to do it, I think, that is going to reduce your chance of error is to get your whole numbers into fraction form. And so I'm just going to rewrite the -26 thirds because I haven't done anything with that yet. It's going to come down unchanged. But this 3, I need to rewrite it so that it has a denominator. So I'm going to add something that has a common denominator. but that whatever's up here helps retain the value of 3. So give me a number that when you divide it by 3 equals 3. Well, hopefully you said 9. 9 divided by 3 is 3, right? You'll be amazed at how many different ways you can take any value and rewrite it, and it can look totally insane, but it still has the same value. That's another cool thing about math is you could have, if you needed to, you could have done, if this was a 9, you could have done 27 over 9, and that would have been 3 also. So there's really a wide variety, but we chose this one because it had the denominator of 3. We're going to do that over here too. So I need this to be a negative number that's over 3, but the value of this has to equal to negative 7. So what's a number that you could divide by a negative 3 to get 7? Well, hopefully you said 21. And the 4/3 comes down all by itself. So I didn't change the value of 3 and negative 7. I just changed how they looked, which we have the power to do so. So now when we take a look, I've got negative 26 plus 9. When I combine that, that's really 9 minus 26. I should get a negative 17/3. Again, still not looking too pretty, is it? But that's okay. We got to trust that we've been doing this right and remember to breathe. So this is a negative 21. Oh, remember, actually, I didn't say this. When you're adding and subtracting fractions, you're only adjusting the numerators. The denominators stay the same. So notice I did not change my denominator. Okay, so it's only in multiplication and division where you're going to modify your denominator. But adding and subtracting, you have to have a common denominator in order to add and subtract fractions, and the denominator in that process will not be altered. So that becomes a negative 17/3. Over here, it's a negative 21 plus 4, which we could think of as 4 subtract 21. And lo and behold, it equals negative 17/3. And here we have it, folks. We have a correct solution because in this process, when we said x is equal to 2/3, the left side did in fact equal the right. And there we have completed our knowledge of proficient level of solving linear equations.
So I hope that video was helpful in helping you understand that content. If you are interested in knowing more about this or another topic, do not hesitate to reach out to me. You can always email. If you have YouTube permissions from your parents, you can comment below and tell me what topics you would like to have added into my video list to help you with your continued math learning. And don't forget, if there is science stuff that you need some help with, I can work on providing materials for that also. So I hope it was helpful. Good luck in all that you do. You're all wonderful people.